Here are the answers to the first few sections of the Unit 5, Part 2 assessment study guide for the quadratics assessment. I'm calling it an assessment, and I'll explain what the test is in just a few minutes. Let's take a look at Section 1, which is over factoring quadratics. And when we're factoring, remember what we're looking to do is to get our equation into that factored form with those two parentheses. So let's go ahead and get started. Our first one, I notice my a value is equal to 1. That means I can just use my x model to help me out. I don't see a GCF, and I don't see that a and c are perfect squares. So we're going to use our x model. I'm looking for numbers that multiply to make negative 12 while adding together to make 4. Since I know this is negative, I know one of my answers will be positive, one will be negative. And the two numbers that multiply to make negative 12 and add together to make negative 4 are negative 2 and positive 6. Once I have my two factors, we're going to rewrite those in parentheses as x minus 2 multiplied by x plus 6. We're not asking to solve here. We're simply just asking to write the quadratic into factored form. If it said to solve, then we'd set them equal to 0 and get x equals 2 and negative 6. But again, we don't have to do that in this point. If you ever want to check to see if you're right, what you can do is make an area model and see if your work is correct. Look at number 2. Here we're factoring x squared plus 11x plus 18. In this case, our a value is a 1. A and c are not necessary or are not perfect squares. A is, but not c, and there's no GCF to factor out. So we're going to start right again with our x model. We're looking for numbers that multiply to make 18 while adding together to make 11. The two numbers that multiply to make 18 and add together to make 11 are 2 and 9. So our answer in factored form is x plus 2, x plus 9. All right, let's look at number 3. When I look at this, I have 4 and 1. 4 and 1 are both perfect squares. So that means that this is a perfect square trinomial. And I know that because of 3 reasons, one of which I just mentioned. I can take the square root of 4 and the square root of 1. The square root of 4 is equal to 2, x, and then the square root of 1 is equal to 1. And just to check, is 2 times 2x times 1 equal to 4x? Yes, it is. 2 times 2 is 4, with the x times 1 is 4x. So again, I know this is a perfect square trinomial. So to factor this one becomes very simple. We're going to take our 2x from the start here, and we're going to put that in both of our binomials. I see that I have a subtraction of 4x on both sides, or in the original problem, excuse me. And then we're going to subtract 1. That 1 comes from right here. And again, if you need to check with perfect square trinomials, just make an area model and you'll see that you will get the same exact problem. Always look for perfect square trinomials. What you're looking for again is that a and c are perfect squares and that your b value is equal to 2 times your a value square rooted and your c value square rooted. Very good. Let's look at number 4. This is initially one where people get really stuck and they think it's pretty difficult, but this problem is just a difference of squares problem. Now, difference of squares problems, a way to identify those is that a and c are perfect squares, which 1 and 9 are perfect squares, and there is no b value. If you notice, there's no term in between these that has an x on it. Like this one had a b value in number 3. This one doesn't. So from here, we're going to take the square root of a and c. The square root of 1x squared, square root of 1 is just 1x, and then the square root of 9 is equal to 3. So our answer with difference of squares is 1x plus 3, 1x minus 3. Notice how my signs are different. Kind of helps you with the difference of squares idea. Also notice, again, if I made an area model to check, I would see that I would get this answer again. Number 5 is just like number 4. I notice that a and c are perfect squares. And I notice there's no b value, so I know this has to be a difference of squares problem. So to factor a difference of squares problem, I'm going to take the square root of a, Square root of 25x squared is just 5x. Square root of c, square root of 4 is just 2. So my answer is 5x plus 2 multiplied by 5x minus 2. All right, number 6. I'm looking at this one, and my first thought is that my a value is not equal to 1. So I'm going to try and factor out the GCF to make sure I get an a value of 1. Just going to simplify my process a little bit. So the GCF between 2, 6, and negative 108 is just 2. So I factor that 2 out of my problem, and 2 times what gives me 2x squared? That's x squared. 2 times what gives me 6x? That would be 3x. And 2 times what gives me negative 108? The answer is negative 54. If you need to use a calculator to help you do that, go ahead and do so. That's no problem at all. Now from here, all I have to do is factor what's inside the parentheses now. And as you can see, I have a much simpler problem in this case. So I'm looking for numbers that multiply to make negative 54 while adding together to make 3. Now remember, when we are figuring out these two numbers up here, multiplying to make a times c is what you get here, and adding together to make 3 excuse me, is what you get there. So from here, our answer, we're going to get a 9 and a negative 6 for our two factors. 9 times negative 6 makes negative 54. 9 minus 6 gives us 3. So our answer, not forgetting the 2 out front, is x plus 9 times x minus 6. All right, let's take a look at this one. On number 7, I'm looking for a GCF between 2, negative 9, and negative 81. And unfortunately, the GCF here is only a 1 because the maximum GCF here for 2 is a 2, but 81 is an odd number, so it's not divisible by 2. So in this case, it's one of our factoring problems that we're going to have to use the X model and grouping. So from here, we're looking for numbers that multiply to make negative 162 and add together to make negative 9. So here's where we're going to be playing around with some of our factors. We're looking what we can divide 162 by to get a negative 9. So I'm going to play around with that as well. Basically what I'm doing is I'm dividing 162, negative 162, by its factors to see if I'll get numbers that add up to make negative 9. And I just did. I found out that 18 and 9 multiply to make 162. But here's the problem. When I add these together, I'm going to have to get a negative 9. So which one has to be negative? Negative 18 or negative 9? The answer is negative 18. Negative 18 and positive 9 gives me negative 9. So from here, since my a value is not equal to 1, I'm going to factor by grouping now. My answer isn't simply x minus 18, x plus 9, because that would not give me this answer if I were to factor it out, or factor it. So let's go ahead and write out our steps again. We're going to write the original 2x squared. We're going to write negative 18x plus 9x minus 81. So if you remember, when we were factoring by grouping, we took our negative 9x and we rewrote it as our two x's we found here, negative 18x and 9x. So let's group our numbers, and then we're going to look for the GCF between the two terms there. And remember, when we're looking for these, we're looking for the same terms to be left inside parentheses. So what is the GCF between 2x squared and negative 18x? Our answer is 2x. What is our GCF between 9x and negative 81? Your answer is 9. So right away, I know that one of my factors is going to be 2x plus 9 by combining those. Now I just need to figure out what would be inside the parentheses. So from here, 2x times what gives me x squared? That'd be an x. 2x times what gives me negative 18x? Would be negative 9. And if you look at that, x minus 9 also goes here. 9 times x is 9x. 9 times negative 9 is negative 81. So my other factor, or my other binomial that goes here, is x minus 9. Number 8, when I'm looking at this one, again, I notice my a value is not equal to 1, so I'm going to try and simplify that problem. It's great because 5 happens to be the GCF between all 4 of those problems, or all 4 of those terms. So let's factor out a 5 from our trinomial. 5 times what gives me 5x squared? That's x squared. 5 times what gives me negative 30? That would be negative 6x. 5 times what gives me positive 40? That would be a plus 8. And if you look at that, our problem just got a lot simpler to work with. So let's make our x model. We're looking for numbers that multiply to make 8 and add together to make 6. And those two factors are 4 and 2. So our final answer is 5 times x plus 4, x plus 2. Good. Factoring is the biggest battle here when solving quadratics. So good work trying to figure those out. And if you have questions, we can hop on Teams to work with those. All right, let's go to section 2, and then we'll finish out this video. Section 2 says convert to factored form. So we have f of x equals x squared plus 4x plus 12. And we're trying to make it look like factored form, like what we had above. So this value out front here is just going to be the GCF. Well, the GCF between 1, 4, and 12 is just a 1. So we've already figured out our k value, which is great. Now we need to figure out what our factors are. So since our a value is equal to 1, let's go ahead and make our x model. We're looking for numbers that multiply to make 12, add together to make 4 in this case. So when we think about those two numbers, what we're going to have is a 6 and a 2. But the problem here is that 6 and 2 do not multiply to make, or add together to make 4. So I need to rethink about what I'm looking at right here. This must be a negative 12. I think the problem only works when it's a negative 12. So one error there. Sorry about that. I was like, what are these two numbers here? But if it's a negative 12, it doesn't, I'm just changing the problem a little bit to make sure it actually works. So let's try that again. Numbers that multiply to make negative 12 add together to make positive 4. They are 6 and negative 2. So we found our two factors, 6 and negative 2. So from here, let's go ahead and write x minus 6, or x plus 6, x minus 2. And when we notice we wrote that out, we actually are going to set those equal to 0. And we get x plus 6 equals 0, x minus 2 equals 0. So x must be equal to negative 6, x must be equal to positive 2. So that's what we're going to substitute in here. X minus a negative 6 gives us x plus 6. X minus 2 would be x minus 2 here. And look, that's originally what we had here as well. So our final answer in factored form is f of x equals 1 times x plus 6 times x minus 2. All right, last one we're going to work with today. Convert to vertex form. We can either complete the square, or we can use vertex form. We can find the vertex form using negative b over 2a. We're going to choose to complete the square on this one, just to get a little bit of practice. So in order to make this into vertex form, let's go ahead and try and complete the square. We have one x squared tile, one of them right here. We have negative 14 x's. So if I split negative 14 into 2, I would get negative 7. So I'm going to put negative 7 on both sides. I know it's weird to put negative 7, but I'm going to draw 7 lines. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. To complete my square in a negative 7 by negative 7 box, the number of dots I would need in here is 49, because negative 7 times negative 7 is 49. So my answer, converting into vertex form, would be the side length, which is x minus 7, squared, since it's the side length, plus, I had 49 tiles to complete the square, or I needed 49 tiles to complete the square, but I had 50, meaning I had one extra tile there. So I'm going to put a plus 1 on the end. So that is the vertex form of the standard form equation. If you have any questions today and I want me to re-explain something, hop on Teams and I can help you out.